have discussed certain rules like I already told you the outcomes and sample space examples, meaning outcome if the n outcomes are there. For example, what are the uh, results of a particular event or a outcome is in a sample space. Sample space is collection of outcomes O1, O2, On, and where OI represent the ith outcome in the sample space. So what is the probability of getting OI with the associated with the outcome OI, right? Please mute your mics, right? So first that rule is what the probability associated with any outcome must be between 0 and 1. So that is the major thing. The more the probability is near to 1, the more that event is likely to happen, right? The better chances of happening of that particular outcome or event, right? Then 0, this is the notation in the formula of algebraic form, right? And then second one is what? The sum of probabilities over all possible outcomes must be equal to 1, right? So whatever the probabilities are there, if you're going to have sum all the probabilities, it should be equal to 1, okay? Then probabilities associated with events. Events we already have discussed. What is the event? Events is a collection of one or more outcomes from a sample space. If you are going to have one or more outcomes, then we will comprisely call it what? Event, right? Then rule 1 is, what is the rule 1? The probability of any event is the sum of the probabilities of the outcomes that comprise that event. So whatever the event, whatever the outcomes are there in a particular event, if I want to know the probability of that particular event, right? So the probabilities of all the outcomes in a particular event comprises the probability of a particular event. Example that is on your screen. One event is there. What is that event? In which we have rolling down the two dices and we want the outcome 7 or 11, right? So what is the probability of getting 7 or 11? So here outcomes are 2, 7 or 11, and comprisely of 7 or 11, the event is there. So what is the probability of this event? The probability is 6 by 36 plus 2 by 36 as per the rule. All the outcomes in a particular event, when you are going to add it, then the particular probability of that particular events came, right? Here on your screen again the example is there. So probability of getting 7 is what? Probability of getting 7 is 3 4 and 4 3. Like this we're going to calculate and we will get the total frequency of a particular outcome. This one I already told on that day how it will come, right? 7, the frequency is total 6. I'm going to tell you how it will come. 7 3 4. In one dice it is 3, another dice it is 4, then 4 3, then 2 5. In one dice it will be 2 and another dice it will be 5, then 5 2, then 1 6, and 6 1. So total number of frequencies 1 2 3 4, 5, 6, right? Like this it will come. So 2 by 36, and then what is the probability of getting 2 in 2 dices? Then what is that? It will be 5, 6, and 6, 5, right? Then it is 2 by 36. Okay, so I'm going to add this, we will get the probability of an event, right? Similarly, when the example that we have took in our last slide, that is the if what is the probability of repair of a computer in 7 days, right? So here the frequencies are there, days are there, frequencies are there, and here relative frequencies are there that we have calculated on that day, right? I'll show you the example also. I have one data I have prepared, right? So here what happened, associated frequencies are added. So 0.04 is here, right? 0.04 here, outcome of 5, then 6, then 7, they added, these outcomes are 0. So total probability of repair of computer in 7 days is what? 0.032. It means less probability. The example of this is called the graph that is your that is shown on your computer screen. It's a called distribution, probability distribution, right, of a particular outcomes. It's an event, right? So here just see, uh, computer repair time is there, and we have number of days like up to 42, where we have data of what, in 5 days total one computer repaired, like this frequency is there, in 6 days 2 computers repaired. So like this we have calculated the probability also of it, right? So the same thing that they have asked, okay, what is the probability of getting 7? So here we have 0.018. This is a different data I have, right? And here the probability is of 10 computers 0.069. Like this I have made one data, right? So this is what the meaning of this particular PPT, right? This one, relative frequency is there, okay? So then next one is next event, that next concept that we have discussed was what, if A is an any event and the complement of A denoted A raised to C consists of all outcomes in the sample space not in A, right? So here if A is in any event, for example, if any event is going to be happened, the complement is mean that is not included in this event, that is not common one, right? So that rule is what, the probability of the complement of any event A is the probability of A complement equal to 1 minus probability of A, right? Example also we have took, that is the dice example, where event is what, 711, right? So probability of getting A that we have discussed already calculated in our last slide is 8 by 36. Now what happened in a dice is, except 711, what are the other figures? 2, 3, 4, 5, 6, 8, 9, 10, 12. We have excluded this event. So using the rule 2, the P probability of A raised to C. So the probability of getting 2, 3, 4, 5, 6, 8, 9, 10, 12 is what? 1 minus 8 by 36. That is 28 by 36. So this is the another rule. So whatever to computing the complement of an event. Okay. So this is another rule. Then next one, then union of events. So the union of two events contains all the outcomes that belong to either of the two events. For example, if two events is going to be happen, so what is the union of it? So whatever the events are going, whatever the outcomes will be there in the A and B event, it should be added, right? Two events are mutually exclusive if they have no outcomes in common. And another important point is what? These two events should be mutually exclusive. What is the meaning of mutually exclusive? Exclusive? It means that nothing should be common in these two events. For example, if events A and B are mutually exclusive, if two events are there, so probability of getting P A and B, probability of event of A and B is what? PA plus PB, probability of A event plus probability of B event of PA, A or B, right? Or is very important because or is showing that it's a mutually exclusive event, right? So example, A event is what? 711, right? What is the probability of getting the 7 and 11? Is 8 by 36. So probability of A event is what? 8 by 36. Then probability of B event is what? 2, 3 and 12. Now see here, in both these events, nothing is common. Here 7, 11, here 2, 3, 12. So the rule is what? We have to now add the probability of 8 by 36 and 4 by 36. Okay. So this is the probability of A or B. The union of events of A and B equal to PA plus PB, that is 12 by 36. So if two events is going to be happen, and if two events in the this two events are totally mutually exclusive, then what is the rule? Then we have to add the both the probabilities of both the events, right? So this is the another rule. The next one is non mutually exclusive events, where something is common between A and B. So just see here, the notation is what? A and B. Another, in a last slide, when the events are mutually exclusive, then the notation was what? A or B. So the notation here is what? A and B represents the intersection of events A and B. Intersection means certain area is there, certain area is there, certain area like this one, right? This area, this is the common area, right? Like this, when the two events is going to be happen, and if certain things are there that is common in both these events, then the formula is what? PA or B is PA plus PB minus PA and B, right? This one is the formula. So now we're going to have, see how we're going to have calculated. Now see here two events. Two events are what? First one A 2, 3, 12, right? Then B is even number. So all the even numbers are what here? Just see here. All the even numbers are here, right? Even numbers are 2, 4, 6, right? Again 4 and 2. So the probability of even number and the probability of 2, 3, 12, it should be added, and then it should be minus by P and B. P and B means the common one. Common one means common are 2 and 12, right? A and B means 2 and 12. here 2 and 12, and in even number also 2 and 12. So common is, what is the common numbers are here? 2 and 12, because it's an even number. Okay, so here the probability of common number is 2 by 36, because here for getting 2 is 1, then probability of getting 12 is also 1, right? Probability of, if you're going to throw a dice, if you're going to throw a 2 dice, then to getting the 2 we have 1 1, other than this no combination. So 1, and when you go, what is the probability of getting 12? It will be 6 and 6, other than this no combination. So again it's a 1. So 1 by 36 plus 1 by 36 is 2 by 36, right? So what they have did here, the probability of A event plus the probability of B event minus the probability of A and B, that is the common in both, right? And then we'll get the 20 by 36. Okay. Now, what we have learned, we have learned the probability concept. Then we have studied the different rules that probability should be 0 and 1. Then we have studied that all the outcomes, when we're going to add, it should be equal to 1. Then we have studied that uh, mutually exclusive uh, events, when going to be happen, then the addition the of outcomes in a particular uh, event, and that probability of that event. For example, if A and B are two events, if both the events are mutually exclusive, if nothing is common in that, then probability of A event and probability of B event, when we are going to add it, then the probability of A and B will come, right? Event will come, right? So we have like this, and when this have when they have mutually exclusive, when common is there, then probability of A and probability of B, right? Two events is minus by the common event, right? So these are all outcomes in the particular event. There is also outcomes in a particular B event, and this is also outcome in A and B, right? Now we have going to discuss about what is joint and marginal probability. The probability of the intersection of two events is called a joint probability, right? The probability of event, irrespective of the outcome of the other joint event, is called marginal probability. So what happens when the probabilities, when the events are going to be happen simultaneously in the same time, then, and if these two events have certain thing is common, then it's a joint probability, and the probability of event irrespective of the outcome of the other joint, and if both the events are happening simultaneously but both are not mutually exclusive, nothing is have uh, you can say common in both of it, then it's called a marginal probability. The probability of an event irrespective of the outcome of the other joint event is called, right, marginal probability. So here is one of the example that is uh, on your screen. It's an example where we have took a sample of 100 individuals. A sample of 100 individuals were asked to evaluate their preferences for three new proposed energy drinks in a blind taste test. It means that their eyes have wrapped out, and then they have to ask that what is that taste of particular energy drink. So the sample space consists of two types of outcomes corresponding to each individual. Here we have to male females separately and their preferences, and brand preferences will be B1 brand 1, B2 brand 2, and B2 B3 is the brand 3. So define a new sample space consisting of the outcomes that reflect the different combinations of the outcomes from these two sample spaces. So what is the different combinations of outputs should be outcomes are there. So O1 first outcome is what? The respondent is a female and prefer the brand one. Second outcome, what it could be? The respondent is female and prefers brand two. Then third outcome is what? The respondent is female and prefers brand 3. And fourth outcome is what? The respondent is male and prefer brand 1. And the fifth outcome is the respondent is male and prefer brand 2. And the sixth outcome again, what? The respondent is male and prefers brand 3. So what we should have to do, we have to separately want to calculate the probability of each outcome. The probability of each of these events is the intersection of the gender and brand preferences event, right? So here, these are the combinations, possible combinations of an outcome. Other than this, outcomes is not possible. So this is the 6 outcomes, and we have to know the intersection where this particular how this is going to be calculated. Then probability of O1 is what? Probability of female also and B1. So here both the events have certain thing in common. So and both the events are can say simultaneously working or happening. One female is there. One female when what is the possibility or probability of a female uh, who taste a brand one. So it's simultaneously two events are mutually dependent, right? So for that purpose we have to use the intersection concept, and these two events are not mutually exclusive because both are interdependent, right? Female is going to taste a brand one, right? So for this purpose, there is a one particular way of calculating the joint probabilities in an Excel. Energy during survey is there. The joint probabilities of gender and brand preferences are calculated by dividing the number of respondents corresponding to each of the 6 outcomes listed above by the total number of respondents 100. So total number of respondents are 100. So just see here in a particular uh, here just see this is the data, right? Respondent 1 is male and prefer brand 3. Respondent 2 is female and prefer the brand 3. That's why I'm always insisting you people to go for better research options, because through this you can have that kind of able to get a concept of this all technical issues, right? Then if we're going to have take a third respondent, third respondent is male and he also prefer the brand 3. Like this, our data is there. And here I have told you in my last classes about the pivot table, right? Pivot table, I have told you about it, through which we have calculated this thing. Now see here, what is the example we have took? If the respondent is female and prefer brand B1. So if the respondent is female and prefer brand 1. So what is the probability here showing? 0.09. Okay, so this is the probability here, and now I will going to have show you in right now. Maybe we're going to continue in next class also, right? Now I'm going to show you how this data can be important for us, and how are we going to have calculate the probability over it. Now this is the example. We have data. Here we have respondents, right? Here we have respondents. Here we have gender. Here we have brand preferences. So we have total here. Just see a total number of respondents are 100, right? And we have 100 respondent, and everyone, for example, 51st respondent is male and prefer brand 2, right? Like this we have data, respondent number, the gender of that respondent, and what kind of brand it preferred, right? Brand 1 that respondent has preferred, and respondent 1 is female. Like this I have a data now, through which I can calculate this that I showed you just now in the PPT, right? Here the female prefer the brand 1 is 0.09. So how it calculated? Through the pivot table. I'll show you again how we're going to have calculated. Here is our data, energy drink. Now I should have to select the whole data, then insert, and here the pivot chart option is there, right? Data is already selected here, the whole data, right? Okay, now we don't want a graph, so just click on that graph and put the button delete. Now we have, you see here on your right hand side, these are the all options. We have 3 columns there: respondents, numbers, genders, and brand preferences. Here we have 4 fields under which we have to drag these fields. So first is what? Brand preferences. Now see here, brand preferences came in the word column side. Here also we have to now it in the row side, we need in the 1 by 1 in column, right? So I have to drag this to the column. Okay, now brand 1 is there, brand 2 is there, and brand 3 is there, right? Now I want gender, right? I click on it. So gender is in rows and brand is in common, right? See very carefully. Now I click respondents. So here in values, some of respondents came automatically by default. But what we should have to do, we have to now change that setting of the value. We have to click on it. Value fields settings are there. We have to click on it, and now the different options came here, right? Then that is I put it on count and then put the button OK. Now what happened? Instead of summing, instead of summing the values, it calculated the value, right? It calculated the how many females are there who prefer the brand 1, how many males are there who prefer the brand 1, like this 9 25. It means that females are in the whole data, 9 females are there who prefer, those are preferred brand 1. In the data, 6 females are there, those are preferring brand 2. in the same data, 22 females are there who is preferring brand 3. So brand 3 is mostly preferred by the females. Now male is 25 who preferred the brand 1, then male who preferred brand 2 are 17, and those are preferred brand 3 are 21. Right? So it's a row total and it's a column total 100 data we have. Right? Now what we have did in that example, what is the probability of the respondent should be female and prefer the brand 1.